We're going to talk about solving logs and scientific notation. So even when I was in high school in the 90s, to solve log problems, we use calculators. But there's also a log table. Logs are important when we're talking about how we measure hearing. Scientific notation is also important because conventional notation is very cumbersome, and it would be easy to drop or add an extra zero without noticing it. For example, sound intensity, the number would be written 1 times 10 to the negative 16 in scientific notation, or zero point 0 times lots of zeros in regular notation. So scientific notation is much less cumbersome. I can't even say that long number, and it's therefore used when we're calculating logs. We use scientific notation. So 100 equals 10 squared because 100 equals 10 times 10. 1,000 equals 10 times 10 to the third. 2,000 equals 2 times 10 to the third in scientific notation. So a number is written as the product of a simple number, that is 2, also known as the coefficient, and the base of 10 raised to some power. So here are some more examples. We have our coefficients 2, 5, and 6 times 10, the base raised to some power. Or, in the example of 5,500, 5.5 times 10 to the third. The simple number, which is the first term in the product, is called the coefficient. And in scientific notation, the coefficient is always multiplied by a base of 10 raised to some power. And 2 decibels are sufficient. Here is another example of conventional notation compared to scientific notation. When the exponent is a positive number, you move the decimal place to the right. When the exponent is a negative number, you move the decimal place to the left. Again, more examples. With scientific notation, remember there should always be a coefficient, a whole number, followed by a decimal point, and then 2 values after that. The base is 10 raised to an exponent. You simply count to the right if the exponent is positive, or to the left if the exponent is negative. Again, some more examples. 12,500 is the same as saying 1 decimal point 25. We have 2 decimal spots times 10 to the 4. You'd simply move the decimal spot 4 ways over to the right. In the example of 12,541, it's okay to just keep 2 decimal values, so you can drop the 41. Remember, positive numbers move to the right, negative numbers move to the left. When the exponent is 0, the value stays the same.